Today we will learn about functions and how to identify them. Before we get started, we need to know some vocabulary words or key terms. A relation is where you pair numbers in one set, the domain, with numbers in another set, the range. Now, a function is a relation in which each input has exactly one output. A domain is a set of input values. A range is a set of output values. Next, let's have a look at a set of ordered pairs. Does this set represent a function, and how do the key terms fit in the situation? Well, if we look at 3, 5, 2, 1, 1, 4, and 5, 5, we know that 3, 2, 1, and 5 are our input values. There are X values. We also know that 5, 1, 4, and 5 are our output values. These are our Y values. To make a mapping diagram, we put all of our input values on one side and all of our output values on the other. So our domain goes on the left and our range on the right. Notice how, even though 5 appeared twice in the range, we only wrote it once in the mapping diagram. Now we're going to draw arrows mapping each input to its corresponding output. So we map 3 to 5, we map 2 to 1, we map 1 to 4, and we map 5 to 5. Since each input has exactly one output, this represents a function. Notice how each input only has one arrow coming off of it. Next, we're going to see what happens when you graph the function and learn what the vertical line test is. So, if you graph a function, that means you find each point on the graph. So, for instance, 3, 5 would be here, and plot it. Let's do the same for positive 2, positive 1, 4, and positive 5, positive 5. Now that we've plotted our points, we're going to draw vertical lines going through points on our graph and make sure that none of our lines pass through more than one dot. So notice how each line only passes through a single dot. Well, that means that our set of ordered pairs passes the vertical line test, making it a function. This function has the input, the X values, or the domain values of 1, 2, 3, and 5. The output, or Y values, or the range, would be 1, 4, 5. Let's try another example. Does the set represent a function? So the points are 1, 5, 2, 6, 3, 7, 4, 8, and 3, 9. This means that our domain would be 1, 2, 3, 4. And our range would be 5, 6, 7, 8, 9. We can choose a method to check. If you make a map, you would put all of your domain values, your X's, or your inputs on the left. So 1, 2, 3, 4. Notice how we only write 3 once, even though there's 2 points with a 3. Now let's write our range values, our outputs, or our Y values on the right. So we have 5, 6, 7, 8, 9. Now that we've done that, we can draw our arrows connecting each input to its corresponding output. So 1 is 5, 2 is 6, 3 is 7, 4 is 8, and 3 is 9. Notice how the input value 3 actually has 2 arrows coming from it. That means that this relation is not a function. Why is it not a function? Because 3 has 2 outputs, and a function must only have one output for every input. Now, if you chose to check this the vertical line test way, you would have to find the points. So 1, 5, 2, 6, 3, 7, 4, 8, and 3, 9. And what you'll see is that although you can make a vertical line in some places and only go through one dot, it's not true for everywhere. So like if you draw a line here, you would go through not one but two dots. That means we fail the vertical line test. It doesn't matter if you can draw some vertical lines that only have one dot. If you can draw a single line that has more than one point, then it fails, and we do not have a function. Now, pause the video and check these graphs with the vertical line test. Are they a function or not? Well, for the first one, it doesn't really matter where you draw your vertical line. You're only going to pass this line or relation at one point. So, yes, this is a function. If you look at the one on the right, you'll see that you can draw a line that passes the relation in 2 points. So, no, it is not a function. Now let's look on the bottom. Once again, you can only pass through at one point no matter where you draw your vertical line. So, yes, this is a function. And for the one on the right, it doesn't matter where you draw your vertical line. You still have only a single point on the relation or on the line. So, that means that, yes, this is a function. Make sure you are drawing vertical lines or up and down lines and not horizontal lines, left to right. Now, pause the video and try these examples. Do the tables represent the function? Use a mapping diagram to check. Well, for the first table, remember our x values are our inputs. So we're going to write those in the first circle. We have a -4, -3, +3, 4, and 5. Now, our y values are going to be our outputs. So we need to write those on the right. And our outputs are all either 2 or 6. Now, let's draw arrows or lines connecting the inputs to the outputs. Well, here we have 3 goes to 2, -3 goes to 6, 4 goes to 2, and -4 goes to 6. We also have 5 goes to 2. Notice how in this table every input has exactly one output or arrow, so this is a function. Now let's look at the second example. Once again, our x values will be our inputs. So we're going to put 0, 1, 3, 5, and 7 on the left. Then we know that our y values have to be our outputs. So we're going to put 0, 1, 2, 5, and 6 on the right. Now let's draw our arrows mapping our inputs to the corresponding outputs. So 0 goes to 6, and then 1 goes to 2, 3 goes to 1, 5 goes to 5, and 7 goes to 0. Once again, every input has exactly one output arrow, so this table represents a function. Now here, our inputs are x values, so on the left, we're going to write 3, 6, 9, and 12. On the right, we have our y values, so our outputs are going to be 1, 2, 3, 4, 5. If we draw our arrows connecting our inputs to our outputs, we get 3, 1, 3, 2, 6, 3, 9, 4, and 12, 5. In this case, you can see here that 3 actually has 2 outputs or arrows going from it, making this not a function?